You are watching the 9.3 lesson video on measures of central tendency and standard deviation. So again, with this lesson, we are still talking about only one variable data. And in the next few lessons, though, we are going to change that to two variable data, or bivariate data. Right now, we're just dealing with univariate data, as you can see in exercise number 1. So we're taking a survey, or 12 people were surveyed on the number of passwords they currently have to remember, and the results are in ascending order, which I really like that word. Ascending means from lowest to highest. You can also see descending, and that would be from highest to lowest. Right now, it's asking us to state the median number of passwords and also the mean number of passwords to the nearest tenth. Well, when we have this set of data, it's already organized for us. It's a very small set of data. I don't need to rely on my technology to help me, but I will be showing you ways that our calculator basically does all of this for us. But just so that we can get a memory refresher of what the median and the mean is and how we can actually find it by hand if we ever need to, let's do this in exercise number 1 because the set's small enough. So the median is the middle value. And when I calculate the middle value, I just count in from both sides equally. Some of you might also say, well, you know what, Mrs. Ruscio, it has to be between the 6th and the 7th number of passwords that need to be remembered because the survey had 12 people in it. So what is the middle between 2 and 3? Well, that is 2.5. So our median is 2.5. Now, in order to find the mean, what we're going to do is we are going to add up all of the numbers, which you can see I've done that on my calculator, and I got 29. And what we also have to do then, in order to find the average, is divide by however many people were in the survey. And I always am going to divide by the number with a decimal point, or I shouldn't say always, but I know that 12 is not going to go into 29 evenly, and if I just push enter without it, what ends up happening is I get a fraction, and I really would rather just have a decimal output. So if I put a decimal into my calculator gives me a decimal out. And it says to round to the nearest tenth, which I'm so glad it does, because otherwise, I would have to write a repeating decimal, but I think 2.4 gets the point across. Now, there's one more way that we can find the mean on our calculator, and all you have to literally do is type in mean, and it opens a set of parentheses, or you can open the set of parentheses, but what's important to do is you need to also add in set notation. And then in that set notation, you are just simply going to list all of the numbers. There's 3 ones, how many twos? 2 twos, 4 threes, 1 4, and 1 6. And push enter. You also are going to get the 29/12 as your answer, and you can change that to a decimal however you wish. But that's just another way to find the mean if you don't want to add up all the numbers and then divide by the total if you're not sure how many there are. All right, let's move down to exercise number 2. And students in Mrs. Oakfor's algebra class were trying to determine if people speed along a certain section of the roadway. And what they did was they collected the speed of 20 vehicles and put them in this table. Now you can see that there are not 20 different speeds because what they've done is recorded this in a frequency table. So there were 5 people, this is just an example, there were 5 people who went 35 miles per hour. So what we can do is we can create, we can actually, because there's so much data in this set, we can use our calculator to help us. So we are going to add a listen spreadsheet page. That's 4. And at the top, we'll just label it with the title. So we're dealing with speeds here. And we'll skip the equals line, and I am going to type in all of my numbers. So 29, 33, there's two 33s, and then there's four 34s. And I'm going to do this until I get to the very end of my table. So you can pause the video and do the same yourself. And once you get to the bottom of the list, it's always important to make sure, first of all, that you check to make sure that you didn't miss a value. Odds are I don't think that I did because there were 20 vehicles and I'm in the 20th column. But what you always have to do is push enter at the end of a column. You never want to have that cursor selected. Okay, so next I am going to open a calculator page. And within my calculator page, I'm going to go into my menu. I want to do some statistics and some stat calculations. And since we're dealing with one variable statistics, we're going to click on one variable statistics. We have one list, so we can just push OK. What we just need to do now is tell the calculator what list we want. That's why it's so important to give it a title. If you forgot to put in a title, there's nothing there, and you're going to have to go back, add in a title, and then redo that process again. But we remembered, so we're good to go, and all you have to do is push enter. It gives you all of the information that you need. So we can see the median of our set is 35, so let's add that in there. And the mean, which it doesn't say mean on your calculator, but there's so much information, I actually had to arrow up to find the mean. The mean is the very first one that they give you, which is, you probably want to write yourself a note here, the mean, but this is also on your study guide. Mean is X with a bar over it. So the mean is 36.1. Okay, so the mean and the median are different. Let's read on. So B says the speed limit is 35 miles per hour. Okay, so based on your results from part A, is it fair to make the conclusion that the average driver does speed on the roadway? All right, so the mean and the median are different. And basically what this question is asking us in an indirect way is which measure is better? What should we use, the mean or the median? Which better captures the data? Well, if you look at the data, you can see that most people, if they're going to be speeding, they are not going really, really, really fast, except for this guy right here, or maybe it's a girl, I don't know. They're going 54 miles per hour. And what do you think that 54 does to the mean of the data? You are right. It is going to make the mean slightly higher than what it should be because of this value, we call this an outlier. So is it a fair conclusion to say that the average driver does speed? I would say probably not. The outlier is causing the mean to be higher. Oops, so let's write that in a sentence. All right, so what I wrote here is, it is not fair to conclude the average driver speeds on this roadway. And let's talk about why. So the outlier 54 skews the mean, so the median is actually a fair representation of the data. All right, let's move on to exercise 3. Exercise number 3. It says to determine which TV programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? Okay, so we're looking for a fair sample. Basically, we don't want our data to be biased. We don't want anyone to, like you wouldn't ever go to, let's say, a pet store and be like, do you like pets? Most people are going to say yes, because why else would you be at a pet store? Unless, maybe there's a few people in there that were buying for somebody else's pet, but odds are you're going to get some biased data, and we don't want that. So in addition to picking our answer, we got to explain our choice and why the others are inappropriate. Okay, so let's go through our choices. Okay, we're trying to determine what TV programs are the most popular. So we want to stay away from any area that is going to maybe have us pick a station that has a lot, or maybe one of the places would be linked to a TV station. So one, a baseball stadium. Do we have any shows or TV channels that relate to sports? And the answer is yes. So this is probably not the best. Okay, a concert hall. So music, people are going to listen to music when they're there. Well, we do have a lot of music channels on TV, so I think that's probably, again, not the best. Okay, a grocery store. All right, well, so you might argue, yep, there's a Food Network, but wait a minute, let's think here. Um, the difference between a baseball stadium and a concert hall is that people are picking to go to those places. A grocery store, everybody has to eat, no matter what. So, I know lots of people who actually hate going to the grocery store, but might like to watch the Food Network or, do other things, but you have to go to the grocery store. So that seems to me right now that it would be a pretty fair sample of people if we interviewed them. Let's read on. So a comedy club, again, there's a comedy network, there's lots of things that could be related. You are picking to go to a comedy club. No one is forcing you to go. You don't need a comedy club to survive like we do with the grocery store and food. So let's get rid of 4. So answer choice 3 is the winner. Now let's explain. So the grocery store would give us the most fair sample since the other 3 locations would contain bias. And we talked about why, because you're picking to go to those places, you're more likely to enjoy that and probably more likely to enjoy those different TV programs or stations. Okay, so the next topic that we're going to talk about is what we call variation in a set of data. And what we're actually looking for, we're going to talk about 2 different things. So we're going to talk about the IQR, the interquartile range, and we are also going to talk about standard deviation. Okay, so let's talk about exercise number 4. They give us 2 data sets, and they have the same exact mean, but differ within the variation of the set. You can see that data set 3 goes from 3 all the way to 11, where data set 2 only goes from 5 to 9. Even though they have the same mean, the data is a little bit more spread apart in data set 1. So let's use our IQR to help us to kind of see this or put a value to this variation. Okay, so what is the IQR? Well, the interquartile range is the difference between the 3rd quartile and the 1st quartile. Basically, if I were to write a formula, I would say quartile 3 minus quartile 1. And remember, when we're dealing with the quartiles, we're dealing with like a box and whisker plot. So we're really looking at the difference between this and that. Okay, so what we are going to do right now, I am going to pause the video, but what I'm going to do is I am going to add a page, I'm going to add lists and spreadsheets, and I'm going to type in both data set 1 and data set 2, and I'm going to label them. And I'm going to do this all on my calculator. So here I have my 2 sets typed into my calculator. The next thing that I'm going to do is I'm going to run some 1 variable statistics for both of these sets of data. So even though I typed them into 2 separate lists, it's not considered 2 variables yet. I'm just dealing with one data set and another data set. So I'm going to add a calculator page and just go through the works again. Statistics, after I hit menu, stat calculations, 1 variable statistics. I only have 1 list. And let's pull from set 1 first. That's what I had it labeled as. And then just push enter. So did they give us the 3rd quartile and the 1st quartile? They sure did. So my 3rd quartile is 9.5, and my 1st quartile is 4.5. And to get the IQR, we just subtract 9.5 minus 4.5, which gives us 5. Let's do the same exact thing now with our 2nd set of data, so that way we can compare. So I'm just going to change this to set 2 instead, and here we have our quartile 3 being 8, and our 1st quartile being 6. 8 minus 6 is 2. So they're saying the difference from the top of the box to the bottom of the box in our box and whisker plot for data set 1 is 5, which would make sense. It just means that our data is a little bit more spread out. And same with data set 2. Now, we can also talk about variation by using standard deviation. And standard deviation, you can go pretty deep into standard deviation. We are definitely not going to do that in algebra, but what we do need to know is where you can find it on the calculator and what it actually means. So on our calculator, it appears as sigma x. So what we're going to look for in each of the data sets, I can actually see it right now. This is my data set 2. I didn't change anything on my calculator. My sigma x, sorry about that. There's a dog barking. I'm recording this video at home. Okay, so what we are looking for is sigma x on our calculator rounded to the nearest tenth. So nearest tenth here would be 1.4. And again, this is data set 2. And all I need to do is scroll all the way up to data set 1. And if you're not sure, just keep arrowing up. We can see sigma x is about 2.7. So again, we can see using standard deviation that the standard deviation is bigger for data set 1, just like the IQR, because the standard deviation tells us on average how far a data point is away from the mean of the data set. So the bigger the standard deviation, the bigger or the greater the variation within a set of data. So our last question is exercise number 6, and there's a farm studying the weight of baby chicks after 1 week of growth, and they record all of their weights, so all 20 chicks' weights down below. They're not in any type of order, but that's okay, because what I just did was I typed them all into a list on my calculator, and what we have to do is find the mean, interquartile range, and standard deviation. So the perfect thing about this is I'm going to do everything on my calculator, and when I need to, I'm going to round to the nearest tenth. So add a calculator page, one variable statistics, and I labeled my list chicks. All right, so to find the mean, remember we have to scroll up. That's our x bar. Our mean, perfect, is 3.7. I don't have to round. The interquartile range just requires a little bit of calculations, but not much. So my quartile 3 minus quartile 1, so that's 5, minus 2.5, which is 2.5. And it says, you know what, it says include appropriate units. So what we're dealing with is chicks. And lastly, we need to get our standard deviation. That is sigma x, and rounded to the nearest tenth is 1.7. Again, we're dealing with chicks. It also says that we need to give an interpretation of the standard deviation. Okay, so what this means is on average, a data point, okay, is going to be about 1.7, and I said chicks. This doesn't make sense. That should be, actually, all of these. Let's fix these. These shouldn't be chicks. These all should be ounces. We're not dealing with the number of chicks. We're dealing with the weight of the chicks, right? It says ounces. Yes, ounces. Okay, so on average, the weight of a chick is about 1.7 ounces away from the mean, and the mean is 3.7 ounces. And we could keep adding that multiple times within like 2 standard deviations, and we could either go above or below, but again, I think that's getting to be a little bit more detailed for what we need to talk about in algebra.